There we go. So you were saying something about you didn't understand like the letters and things like that. So
Yep.
the first thing you got to recognize is um, whenever you're doing representing numbers in other bases, this isn't even a conversion thing. This is just representing numbers in bases, base 10, base 2, base 15, whatever it is. You have an alphabet. So 0 through 9, that's our base 10 numbers, right? And we're comfortable with those. You've been using those your whole life. Well, after 9, if we want to represent numbers in bases greater than base 10, we have to move into the alphabet because we need single digit characters because we won't be able to tell the difference if we're trying to represent the number, let's say 1, 3, 5 in some number. We don't know if that is a 1 followed by a 3 followed by a 5 or if that's a 13 followed by a 5. Make sense?
Mm-hmm.
So we need to have single digits to represent these. So what we do is we move into the alphabet. So that allows us to represent numbers up to base 36 with the English alphabet. All right, so a 9 is a 9, a is a 10, a B is an 11, C is 12, and F is a 15. Make sense?
Yeah.
All right. So now any base, if we're talking about base 2, legal digits are 0 and, well, let's say 0 to 1. Base 8, legal digits are 0 to 7. Base 10, our base system, it's 0 to 9. So it's 0 to the base minus 1 are the legal digits in that. Base 16, which is hexadecimal, legal digits are 0 to 15, or we look at it as 0 to 9, and then A to F. Those are the legal digits you can use in those languages. Does that make sense?
Yeah.
Okay, so now those are the bases that are kind of common bases, but we can then randomly pick a base. I could say base 4 or base 5, which isn't necessarily a base that we commonly use or something. And what are the legal digits in base 5?
0 to 4.
0 to 4. All right, so that all makes sense?
Yeah.
All right, so then we have two patterns for conversion. So we have convert from decimal to any base. So if you're starting with a decimal number and you're converting it to any other base, then what you do is pick your favorite, pick your favorite 3-digit decimal number. Favorite, pick it.
212.
212. Okay, so you want to convert 212 now. Pick your favorite base between base 2 and up to base 36. Doesn't matter what base you pick, because I want to really prove the point here that it's the identical pattern.
Base 15.
Base 15. Okay, so we're going to convert this guy. We're going to say to base 15. So what we're going to do is we're going to take our decimal number and we're going to divide it by 15 over and over and over again. So 212 divided by 15 gives us 14 and some change. So 15 goes into 212 14 times. 14 times 15 gives us 210. So we have a remainder of 2. So we'll record that remainder out here. So this is 212 divided by 15. This is 212 mod 15 is what goes over here.
Okay.
The remainder. So far, so good?
Yeah.
14 divided by 15. How many times does 15 go into 14?
0.
0 times. 0 times 15 is 0 with a remainder of 14. We know we're done when we get a 0 there. All right. Then we read our answer from bottom up. So we have a 14 and we have a 2. Now we've already said we always have to have double digits. So we have our single digits. We need to convert that 14 into its alpha equivalent, which is going to be E. So this is 10, 11, 12, 13, 14. So an E is 14. So this 14 here is actually an E. So our answer is E2. We read it from bottom up instead of top down. That's how we get our answer. So that's E2. Make sense?
Yep.
All right, if I just copy this, let's stick with your same favorite number, but let's go to base, you want to do base 8?
Sure.
All right, so what do I do first?
Divide by 8.
Okay, and I'll help you out with a calculator here. So that gives me 26.5. So what do I write where?
You put 26 on the next line down,
Okay,
and then you multiply 26 times 8.
all right, which we're going to have I'll just let you do it. So that's 208.
Okay, so then you put 4 out on the end of the...
Yeah, the difference between 208 and 212 is the remainder, so we have a remainder of 4.
Okay.
All right, what do we do next?
Divide by 8 again.
Divide by 8. 3.25.
Put 3 on the next line down, and then you put a 2 on the next line.
Okay, because 3 times 8 is 24, with remainder 2. Next.
Divide by 8, that's 0.
Okay,
And the remainder on that line would be 3.
yep. And then what's our answer?
324.
324. So that's converting from decimal to any base. So the only special thing you need to remember is whenever you have something that, did I actually overwrite it? Oh, whatever. Whenever you have something that is 2 digits, you need to convert it to its letter. Make sense?
Yeah.
So identical pattern when you're going from decimal to any base. Period.
Okay.
Good on that side?
Yep.
All right. So then we have the pattern convert from any base to decimal. All right. So let's take this same number. Let's do 324.
Okay.
So we're going to say 324 from octal, which is base 8, to decimal. All right, so what I'm going to do here is I'm going to spread my numbers out a little bit. That way it's you'll see how I'm kind of doing this. Now, we're going to assume, I'm going to call it, instead of from any base, I'm going to call it from base n to decimal. Okay? So this guy is in the n to the 2's place, n to the 1's place, n to the 0's place. Or in this case, since n is octal, 8 times 8 is 64. 8's 1's place. Make sense?
Yeah.
So on the far right, we're always in the 1's place. And then you multiply it by the base. And you multiply it by the base again. So if this was base 2, we'd say this is the 1's place, the 2's place, the 4's place, the 8's place. Base 8, it's the 1, the 8's, the 64's. Base 10, this is the 1's, the 10's, the 100's, the 1000's, so on and so forth. So far, so good?
I think so.
And then what we're doing is we're summing everything up. So we're going to take the value down here, this is the 1's place, times 4. And we're going to add to that, down here, the 8's place, times 2. We're going to add to that the 64's place, times 3. I'll just grab that whole thing there. And that is 212. Which is the number we expected it to be. Make sense?
Yeah.
All right, so let's do another one. So let's do 592 from let's do, actually, I'm going to do 2592 from base 16 to decimal. All right, I'll start off by, so this is 2, 5, 9, 2. All right, just to continue the pattern on here, this is 9 to the third power, right? Or n to the third power. So you just, you don't have to think about it to the powers here. You just, this is always the ones place. Times n, times n, times n as you walk to the left. All right? So, if this guy's the ones place here, this other guy must be, what's the next guy's place? We're in base 16.
16?
16's place. Makes this tougher to type, but we'll just go with that. All right, what's the next guy's place?
16 times 16.
16 times 16, which is 256. And then the next guy's place?
Whatever 256 times 16.
So 4096. All right, so I'll just space these. There. Put that there. Close enough. Okay, and then what's my math?
For that would be 4096 times 2.
Okay, yeah, it doesn't matter which side you start from.
And then plus 256 times 5. And then plus 16 times 9. And then plus 2 times 1.
Oh. 9618. So that is the decimal equivalent. 2592 in hexadecimal is equal to 9618 in decimal.
Okay.
All right, so let me throw you a curveball now.
So what are the different names that the different bases have? I know 8 is octal. Which one is hex? Is that
Base 16.
okay?
So
Are there
base
any other
16,
ones?
binary,
Okay.
is base
so
2,
That's obvious.
and like decimal is base 10.
Okay.
Those are the, let's call those the named ones. So we'll go ahead and do my favorite one here. BAD from base 16 to decimal. So I'm going from a base to a decimal. So which pattern do we use?
Would be pretty much the same as what we did before.
Well, we did two things before. So we have two different patterns we can use. Which of the two patterns am I going to use here? Am I using the one where I divide over and over again, or am I using the one where I do the place?
The place with the multiplication.
Yep. Because we're going from some other base to decimal.
Yeah.
Our output is going to be decimal, so we do the place thing. If our output is some other base, we do the divide thing. Make sense?
Yeah.
All right. So I'll type out BAD here. All right. So now what?
Well, might be helpful to figure out what each letter is.
Okay, so we need to convert them to their numbers, right? Good. So B is a what?
12. Or no, it's 11, isn't it?
Yep, 11. A is a
10.
10.
13.
13. Yep. And it's usually helpful if you just write it out real quick instead of doing the mapping in your head. Bob, I'll be in a few minutes. All right. So now you have numbers associated with it, right? So that was good. You did that first step correctly. Okay, now what?
You would determine which base you're in going to decimal.
Well, we're going to base 16, where we're starting from base 16.
So you would put n to the... well, that's n to the 2.
Yeah, you don't even need to think about that. That might make it more confusing. What's this far right place always?
1.
Ones place. Yeah. So if the far right place starts as the ones, what's the next one over?
16.
Times 16. What's the next one over? Times 16 again?
Yeah, it's
256. Yeah, and you don't have to remember them. Do the calculator. Don't try to remember those things. Just 1 times 16 times 16 times 16 times 16, and you always have the right numbers. Or times whatever the base is. Okay? Oop. Then what's the math?
It would be the 256 times 11 plus the 16 times 10 plus the 1 times 13.
Which is 2989 in decimal. That's your final answer.
Okay.
And then if you want to see that go in the other direction, the pattern, if we went 2989 from decimal to hex, which pattern is that? Is that the divide thing?
Divide.
That's the divide thing. So we do 2989, and we're dividing it by what?
16.
By 16. Okay, so 2989 divided by 16 gives me a 186.8. So I put the 186 here.
Yes.
And then 186 times 16 gives me a 2976. So 76 to 89 is a remainder of what?
13.
13, yep. So 186 divided by 16 is 11.6. So that's 11. 11 times 16 gives me a 176. So 176 to 186 is a remainder of 10. 11 divided by 16. How many times does 16 go into 11?
None.
0. 0 times 16, remainder 11.
11 is B, 10
Yep.
is A, 13 is D.
Yep, so B, A, D.
Not an A.
Make sense?
Yes.
So, pretty easy now?
Yeah.
Exactly 2 patterns, like I said, right?
Mm-hmm.
And the conversion is just the a 10 is an A and 11 is a B. If somebody asked you to convert something greater than 36, then you would ask they would have to give you the mappings beyond Z.
Okay.
That's not something we have to deal with right now, but that's the deal. Cool?
Yep.
All right, so let me stop this. I'll upload the video.